Hi everyone, welcome back to my channel. This is the 14th and the last of the series of the basic Python programming course, of the basic one, the advanced one, the intermediate and advanced one will be later. So I'm Sarjun and you can call me Sarj. I'm a data scientist, a data science trainer, and a mentor to the youth. So before we start, I'd like to seek your cooperation to help me with my socials as I'm trying to reach out to as many people as possible through Facebook, Instagram, YouTube, Twitter. Subscribe, send me a message, DM, and I'll get back to you as soon as possible. Now, getting down to today's session. Okay, we're going to be looking at some of the more advanced libraries, I would say, right? Numpy for data science, right? Numpy, Pandas, and basic visualizations. We're going to be doing just the basic stuff, right, of this. So please do not have very high expectations, right? This is still basic. So we're going to be doing Numpy, Pandas, and Matplotlib for the basic visualizations. So we start with Numpy first. So from the name, Numpy actually stands for numerical Python. This package is mainly used for mathematical and scientific calculations. It uses grids of values and are indexed by positive integers, and they contain numeric values mostly. I mean, even though they can support string values as well, they are more for numeric tabulations and calculations, right? And the array of values can be multi-dimensional. Right? So let's see an example of how NumPy actually is. So in order for you to install the NumPy package, the NumPy package already comes with the Anaconda distribution, but if not, you have to go into command line and type in, go into Anaconda prompt and type in this. If you do not have Anaconda, command line, pip install NumPy, or use this expression if you are installing it from the Jupyter Notebook itself with the exclamation mark, right? So we start off by sorry, import numpy s and p. So that's the first thing. We need to import the package, right? We need to import the package. Then we're going to assign a list variable called age list equals to this values, right? Just to show you that we are going to create an array, an NP array from the age list variable, right? So we're going to create an age array. How we're going to do is we're going to use the NP dot. Okay, when you type in a, when you press tab, all the NumPy functions will come out. I mean, all the A functions, right? There's a lot of functions, right? So you can try, and you can pass in age list as the parameter inside, or as the argument. So parameter and argument, they are used interchangeably. I just want to clear that out. So parameter is usually when you define a function, you name it as a parameter, but the argument is what you pass in as a parameter. Okay, so with that said, let me start my phone. Yep. Okay, with that said, let's move on to check out the type of this age array. So type age array, enter, we do a print of this, and then just to split them apart, and then we will do a print age array, age list, and age array. Either way, the age array first. Age array and age list to see what really is the difference, right? We want to know what's the difference between a list and a. So you can see the class of age array, the type is of numpy nd array, and you can see this is an array, this is a list. You notice that list has commas separating each element, whereas this whole thing is a numpy array, right? So that's very, very important, a very, very important difference that you need to understand, right? Okay, you can also use numpy array to store string variables. So now I'm going to create a variable called book array, and I'm going to assign it with this list, right here. And I'm going to display the type. So I'm going to print type of book array, right? Simple as that, right? And then I'm going to print just this. And then display the array variable. I'm going to display that as well. Book array. That's it. As simple as that. Class of wait. See, that's the problem. When I create a NumPy array, I should do a np.array. See, I was testing y'all, See, I forgot to do this. If not, it's just an array. It's a list, right? I know the difference, huh? Now you see, now it's array, NumPy array, right? Learn. See, there is no comma, so this is an array, right? And it's array because Python tells you it's array, right? I mean, Python never lies, but that's it. Anyway, moving on. Okay, you can also create NumPy arrays using what we call the random function. Okay, so the NumPy's random function creates random variables between 0 and 1, and it creates them in an array format. So let's see how that is done. So I'm going to create random array, right, equals to np dot random. So random is the you can call it the sub library of np dot random. That's the method, right? I'm going to set of size equals to 20. I want 20 numbers inside here, and then I'm going to print this out. Random array. So you can see this is a random array. Numbers are between 0 and 1, and there are 20 numbers. You can count lah, but you should know there's 20. So how do you find? You can do a length on this as well. Equal 20, right? So yep, I mean same thing, huh? Okay. Now, on the other hand, there is a rand method, R-A-N-D, rand method. So rand is slightly different, right? The random values generated will be between 0 and 1 from a uniform distribution, and the dimension of the generated random array should be positive. The default is a single Python float, and yeah, so what we're going to do is we're going to use the rand array instead of the random array. This gathers data from a uniform distribution. So if you're looking at a particular distribution is uniform, you want to mimic that, you use this random.rand. So this is another such function. I'm going to do a 2 by 3 matrix, right? And I'm going to print this out. Okay. You will learn more of matrix and all that in the intermediate version, right, of this course. So I'm just going to just go through the basic ones here first. Okay, so this is rand array, right? So rand array also 2 by 3, we have a random uniform distribution. Okay, on the other hand, we can also create what we call a random normal distribution. So the rand normal, right, is, let's call this rand n array. And that's what I frequently use a lot of times, because when you're doing modeling and all that, you use this random normal distribution. We try to be flex a bit in the statistical side of things, right? So use a random normal. Random.rand, and it comes with the n, random normal. So 2, 3, and then, okay, need some space to make it clearer. Okay, then you print it. print, print, rand, narray. Yep, so that should give you a random normal. So random normal is between, the values are, the values have a mean of 0, variance of 1, right? So it's between what you call a normal distribution, right? You will extract numbers from there. Okay. You can also get information of random numbers using rand integer. So now let's do one where we're going to get numbers from 2 to 9. Okay. But I must put 10 lah. So 10 is the exclusive number, as I said. We're going to get it from 2 all the way until 9. Right. So rand int rand int array value. So now we're going to do rand int instead. So np.random.rand int. So it's going to get integers from 2 to 9, and I'm going to display it, right? So rand int array. There's only one value here, so yeah, let me just put the print sign in front. Yep, that's it. As easy as that. You get 4. So let me try it running one more time. 5. One more time. 8. Yep, so that works. Okay, let's move on. To generate 10 random integers from ran_in, okay, the method is very, very easy, right? So you follow this. Let's see how this is done. So how this is done is basically using our, let's click in my rand_int array is equals to np.random.randint. So you just pass in the first value, okay, as a first parameter. Second value is 100 because it's exclusive, and you want to pull out 10 values, right? So you pass in the third parameter 10. So this is not step, this is the number of points. So you must be slightly different from your indexing, indexing and your for loops and all that. The third is usually step, right? Here it's the extraction. So there's slight subtle differences that you need to be aware of, right? But usually you can just Google and search, and you should be able to get something like this, right? Okay, moving on. Okay, now NP has this range function, a range function. So in the a range function, it also follows something like the range function in Python, right? Where the first parameter is the start value, the second parameter is stop value, and the third parameter is the steps value, right? In that case, the start is inclusive and the stop is exclusive, right? So let's do the NP arrange function. For that, I'm going to create an even num array, np.arrange, right? I'm going to start from 10 till 100. 100 is exclusive, and I'm going to pick out two numbers with the step of 2. So, and I want to display this. Let me print it. Okay, as shown here, you can see they start from 10, 12, 14, all the way with increments of 2, all the way to 98, excluding 100. So it kind of creates that arrange data, but it's all it's a NumPy array, right? Okay, moving on. You can also do what we call okay, there's a typo here. It's not linspace, it's linspace, not linspace. Okay, so linspace method, the linspace method, it's a linear spacing method. So where the first parameter is the start value, the second parameter is stop value, and the third parameter is the number of values required to be returned from the interval specified. So follow this carefully, okay? So in this case, the start value and the stop value are both inclusive in the linspace method, right? So this is slightly a bit different. So let me see how that. Let me show you how this function works. This method, this method works. Sorry, not function. It's a method. So linspace. So I pass in the first value as 1, the second value as 100. So it's going to give me 1 to 100 with 10 values evenly spaced. So how that happens is basically as simple as this. So let me show you. I display this array, print num array. You can see it's 1, 12, 23, 34. You start thinking, 1 to 100, if I say 10 numbers, isn't it 1, 10, 1, 10, 20, 30, 40, all the way until 100? No, actually, if you think about it, 1 to 10 is just 9. So if you really want it from 0 to 100, then you must start from 0, right? Then you will see that actually this is 0, 11, 22, 23, 44, and you're taking 10 numbers, right? So it starts from 0. So actually you want 11 numbers. That's when it's 0, 10, 20, 30, 40. So all these maths, it's not that difficult, but it says that you need to run around with these different values. Okay, so you have to play around with it, right? So changing it back to its original values. Yep. So this is what we're looking at. Okay, there are also different methods, some useful ones. The method zeros will be able to generate a specific shape of arrays variables with 0 values, then define an array variable with this. Let's go. 0 array is equals to, so we call this np.zeros method, and we just say I want 10. So it will just give me just 10 zeros. Right, so I call this a 0 array. Simple, just give me all the 0, 0, 0, 0, 0, right? Okay, similarly, I can also do a 2D version of this NP array, right? So how I can do that is I can generate a 2-dimensional 0 array 2D, right? So how that works is I pass in np dot zeros, okay, but must be a bit careful how I do this. I need to put another bracket in, two sets of bracket, 10, 10, right? I can leave some space here to make it nicer. Okay, then I print out, print 0 array to D. You can see it's 10 by 10, there's 10, and there's 10. So 10 rows and 10 columns, right? Okay, the creation of array variable with more than one dimension, I can also do it with what we call the np.ones, right? So this is the same as zeros, as in place of zeros, it's just ones. Somebody asked me why create these zeros and ones. Sometimes you want to create them first, then populate values in later. There are certain needs of those. Sometimes you want to just create the columns and row first, then later then you fill them up accordingly as required. So sometimes for now you might not really see a need for this. Initially when I learned Numpy, I was like, why would I use that? But trust me, you will use that when you are doing a lot of calculations, or especially when you're doing more deep learning stuff, right? Or machine learning stuff. Yeah. Okay, so here we can also do array with your own specified number. So here I can call a full array to D equals to np.full. So here say I want a 5 by 5 matrix, right? With the fill value equals to 11. So here I can just set it to whatever I want, right? Whatever fill value I want. Oops, that's one underscore. Yeah. So it's a 5 by 5, 11 value matrix. Okay, the identity method will generate a specified shape of array variable with 1 as the diagonal values and 0 as the other value. So it's like a diagonal with ones. Okay, identity matrix is very useful, especially when you do a lot of when you do things like PCA, principal component analysis, you realize that identity matrix come in play quite well. So those kind of stuff. Now I won't go into the details too much. So let me just show you how to do it. Identity array to D is equals to np.identity, right? 5. So it's very simple. That's it. So I need to just print it out to D. You can see it's an identity matrix along the diagonal, right? Obviously, the identity matrix has certain you would want it to be a bit more customizable, right? You want to make the ones maybe up or down depending on how you want to do it. So you can call the np.I method to make that changes. So let's say you want to create something like an I array that has your values by a certain n by m matrix size. So let's say something like np.I will give you the flexibility of setting n equals to 3. So here I'm going to set 3 rows, okay, 3 rows, but m is the column, so 4 columns, 3 rows, 4 columns, and I want my k to be 0. So the k will start with the first, from the first then all the way down, right? So you will see what I mean by that. And then print I array to D, right? So you can see it's like, you can see the one here, one here, one here, right? It just starts from here and then it goes down. So k is equals 0. This is k equals 0 option. Okay, now what happens if you do the same thing, right? But change your k, right? So instead now I'm going to set my k equals to 2, so it will jump 2. You'll jump 2 spaces. Let me, yeah, oops, I think I went high up. Sorry, just bear with me. Yep. So when I print I array to D, you can see that it jumps 2. So instead of starting here, it jumps 1, jumps 2. So it's plus 2 basically. Same thing. If you do the same with a -1, it will go back 1, right? So if I do print I array to D, you see that it goes back, goes down, goes down, goes back, goes down. Okay. The attributes that highlight the characteristics of a NumPy array variable. Okay, so what we are going to do now is we're going to use the shape attribute. So here I'm going to create a book array. So book array 2d is equals to np.array. So I'm not going to forget this now. Earlier I forgot because I was too engrossed in typing out this, right? So okay, so I did this. Now I'm going to pass this in here, right? And I'm going to print display the array variable book array 2d, and I'm going to print simple, and I'm going to display the shape. So this part is where I'm going to type in shape of the array is comma. Okay, so this is the method to call out to look at the shape to d dot shape. That's it. So you can see, oops, what did I do here? Oh, I didn't do it very nicely here. Okay, my bad. Okay, so the shape array is 2 by 3. So you know it's a 2 by 3, 2 rows, 3 columns. That's it. Right? Same thing. I'm going to copy this. Yeah, I'm going to copy this. This is all the same. Right? Right? And display the size attribute. So the size attribute, same thing. Copy this. All I have to do is change the size. So here, I'm going to type here size of the array, and I'm going to change this to size. Easy. Size of the array is 6. And we know it's 6 because we can count 6. 2 by 3, 6. Simple. Now, the D type returns the type of data along with the size in bytes, right? So then we can actually see what is the data type. So in this case, we're going to create a weight array to D equals to np.array. And we're going to pass in this values. As simple as that, right? And we're going to display it. Print weight array. Print this just to, and we're going to print the data type, right? So we're going to print the type of the array is comma. Okay, so I'm going to do weight array.t.dtyp. This is float 64. Simple, right? Okay, before our quick practice, the ndim version returns the axis. The number of axis means the number of axes are not axis dimensions. So how many dimensions is it? We know it's a 2D dimension, but let's confirm it, right? Sometimes we know, but we just want to confirm it. So let me go back up and copy the book array. I don't want to type it out. So this one, I want to copy this, right? And paste it here. That's it, right? And I'm going to print this out. So let me just copy this. Actually, no, I'll just type it out. Print the number of dimensions of the array is, okay, right? That is what I want to do. And I type book array to d.ndim. And you can see it's 2, right? Okay, moving on. Quick practice. You're supposed to define an array, variable book array 2d with this, and display the array variable book array 2d and display the d type of this variable. Explain the d type to display. Go do some research. I'll see you shortly. Okay, welcome back. Let's start this. Okay, so this is quite simple. Basically, you're supposed to create a combination. Okay, so let's do this. Let's take this out, and this is what exactly is wanted to be put in here, right? And what we're supposed to do is we are supposed to display the data type, right? So this case, we're supposed to, I can copy this, right? Just paste this. So the data type, TYPE, quite lazy to type it again, DTYPE, right? So you will see that the output is very much a U. So this is basically a combination of string. Usually it's a string variable. So just saying it's a string. When there's a string there, automatically all the variables are a string variable. If you notice carefully, learn Python is a string, data science journal is a string, Scala for data science is a string, and the other numbers that are put in 20, 23, 18, even though they go in as numbers, they're also converted to a string. Yep. So some points to learn, some points to note. Okay, moving on. The next library we're going to look at is called Pandas. I think some of you might have already heard of it. They are built on top of the Numpy package, right? So again, it contains high-level data structures and manipulation tools built upon the Numpy library, has labeled axes that support automatic or explicit data alignment, has a data frame structure for ease of analysis and review, has efficient calculation frameworks that performs arithmetic operations and reductions that pass on the metadata such as the axis label. So that's where lambda functions, math, reduce, and all that come in. It's very useful, very, very useful. Okay, in order to start, import pandas as PD. Okay, we're going to be creating a list variable product, so let's call it products, is equals to this value, right? I'm not going to copy this. I'm going to copy this. I'm not going to, okay, then I'm going to display it. So I'm going to print products, that's one, and then I'm going to print the type of products, just to show you. That's it. You can see it's actually a class of list. Now we're going to do the next step. We're going to be moving on to create what we call is a series first, right? Using the pandas library. So again, I'm going to create products. Okay, I'm going to use the pandas series method. So I'm going to call products series equals to pd dot. So if you type, you can see that series there, and then you pass in the product as a list, right? And then you can print product series, and you can type slowly, yeah. That's when I type so fast, and then I type other stuff as well. Okay, you can see the data comes out in a vertical manner, and you can see it's a series data set. Okay, you can also create pandas series with numpy arrays as well. So as I tell you, since it's built on the numpy library or the numpy framework, this actually works in the same way. So let me just import numpy as np, and I'm going to create my stock array. I like to do a lot of stocks, right? Because of my background in it, right? I'm passing in this list of variables. Yeah. Okay, and let's create. So here I'm going to do a stock series equals to pd dot series stock array. Simple as that. And I'm going to print stock series. And I'm also going to print the type, the data type of stock series type. Stock series. Again, no surprise there. Series, right? Okay, moving on. For this part, I need to do quite some tedious stuff. So I'm going to create this data frame for you. You just have to create it using a dictionary, and we're going to be using this for subsequent. So I'm going to create a stock dic, and it's super long. Okay, so yeah, this is just to show you the functions and the methods and the power of the pandas data frame. And this is just basic. I'm not even doing anything crazy, right? So this whole thing, right? And I create the pandas series. Similarly, I call stock series equals to pd dot series. I pass in the stock dictionary because it's a key value pair, and I just print stock series. So here, one thing you will see is that, let me just do it and then I'll explain. Okay, so one thing you will see here is that the index here, earlier the index was 0, 1, 2, 3, 4 because there was no index given. But here there's an index is the key and this is the value. So the key is the date of each, and it's a unique date for each stock value. So this is the key, this is the value. This is the key, this is the value, right? So that is in a sense, Pandas is quite smart to understand that in a dictionary, variable goes in, it will take the key as the index and the value as the actual value for the column, right? Okay. Now, moving on, right? We can do calculations using our, okay, so here, yeah, so just as a sign, I've already created the series. So I'm going to use this. So yeah, it's already created, but I'll just copy it from here, right? I'm not going to type it again, right? So I'm going to use what we call the sum method. So I'm going to use sum. So I'm going to use total stock sum is equals to stock. So this takes a series and I can do like a sum. So it will sum all the values from here 150, 150.77, 1043, so all the way until 145.43 and return a value after it sums, right? And then you can print, right, the total stock sum, and you can print the type of total stock sum. Simple, right? You get this value. It's a Numpy float, so you know it's built on top of the Numpy library. Okay, so similarly, I'm going to do the same thing. I can also do a total stock min to find the minimum value of this. So I can do a stock series dot min, and I can do exactly that as well. So print total stock min, and I can do print type total stock min. That should give me 138.2. Yep, that's correct. Class float. Okay, I can again, I can do this. I can extracting the index with the minimum value. I can also do that, right? That is basically using IDX min. So now if I want to know the index where my minimum value is for my stock, I can use the IDX min. So let's try that. So it's 138.2, right? But I want to know which date is that 138.2, right? In this example, right? Total stock index. Let's call it min index. Let's call it min index, right? Total stock minimum index is equals to stock series dot idxmin. So we'll get out the index here because the index here is the date. So I can print total stock min index, and I can print the type of this data. Okay, I think you kind of get this type thing. I'm just doing it just to show you that it's actually a class of string because that is the data, the date. I can also do what we call a dot head as well, right? There's a dot head dot sample. So we're going to be doing some of these, right? So let me run this first. I can do a dot head for stock series dot head. You'll just extract the first 5 rows. Okay, I can also do the stock series dot tail. Yeah, and I can also do a random sample, right? Using the dot sample. Stock series dot sample, and it gives me a random sample value. So this will be from one of the values that from one of the values there, right? Okay. Moving on, I can also pass in values for the dot head to give me up to 10 rows or whatever that I want, right? So I can do that as well. Okay, I can set 10. It'll give me the first 10 rows. Similarly for tail, it will also give me the last 6 rows if I want 6 rows instead of 5 rows, right? TIL 6. Yep. Okay. The good thing about Pandas is it also has this descriptive stats option that gives me descriptive stats about my value. So I can do a stock series dot describe to understand a quick analysis of my data. What's my mean? What's my count? What's my standard deviation? Minimum 25%, 50%, 50% is the median, 75% max value, and all that. You can also sort your data. Okay, so I'll just ramp up a bit. You can do the sort value, stock series dot sort value, right? So the sort value is basically sort values, right? You can do that, and then you can see that it actually sorts the value. So in this case, when you sort the value, right, the value is sorted in ascending order if you just leave it like this. You can also change it to descending order, right? How do you do that? You just set your ascending to false, right? Ascending equals to false, right? FA, sorry, I type FA so fast, right? You can see it's false and it's going down in reverse. Okay, so moving on. So the Pandas data frame, it also has a data frame structure, although looking at series structure. Let's look at the data frame structure, right? PD, right? Let's create a 2D np.array. Let's create this 2D array, and from here we're going to convert it to a data frame. A data frame is basically just not one column, it's multiple columns and multiple rows, right? So we're going to create df equals to pd dot data frame weight array 2D. That's it. I can display it. So usually display for a pandas data frame, it's better to not use the print. I just call out df. If I use a print, it becomes not very pleasing for the eye. So I just use df. Okay. Okay. Again, I'm going to be using the same weight data frame, weight array. Sorry, let me get this out. And I'm going to assign pandas data frame called df again equals to pd dot. So this is very important. Yep, that's it. And I want to display the pandas data frame. Wait, am I doing this right? Sorry. I want to do this, but I want to add columns as well. Sorry, I forgot. Because earlier there's no column names. I want to add column names as well, right? And index. So let me do that. Columns equals to, in this case, this are my column values. So this is the column names. Oops, don't put double brackets, just single brackets. And I want to set my index as well, right? And my index here is John and Wilma. So just follow along. This is just quite a bit more tedious because I'm passing in additional values to make values look a lot more nicer. So I'm passing in. So if you need to pause, just pause the video and then you just copy what you see on the screen, right? And then you see I've now passed in the weight array. I've set the columns as these 3 columns because there are 3 columns and there's 2 index. So basically 0 and 1 will become John and William. So if I press df now and type, you can see, wow, nicely formatted year 2000, 2005, John and Wilma, right? You can also go on to extract the column names, right? So in this case, I want to extract, use a column function. I want to extract the column names. So I can just type df dot columns, it'll give me the columns. If I type df.index, it should give me the index. Simple. I can also extract specific columns. I can put df, I can put in year 2000, if that's what that means, right? You'll just take out that the columns only for that from the data frame, right? So this, as you know, just using a single column extracts a series. If I use the same thing but I put in a double column, it extracts a data frame, right? So it just puts a single column in a data frame, and it looks nicer as well, visually pleasing as well, right? I like the way that looks. Okay, so it depends on whether you wanna. So how you can find this difference is basically doing a type. So I just you print df. Type first, type, and you put in df. Yeah, 2000, and print type df. Yeah, 2000. So it's the same but different because they are different. Yeah, you can see one is a series and one is a data frame. The first one is a series, the second one is a data frame. Okay, so when you're doing indexing, you can't really pass in a value, right? If I do df like how I did it for list, it doesn't work. It throws an error, right? So for data frames, there are very special ways of how to call them out. We call them the ilock and lock methods, right? So just a quick run through df.ilock. If I were to take out ilock, I'll get the first rows value for all, but it's just elongated, right? I can also do a df.ilock. I pass in two-dimensional because it's two-dimensional, and I said I want all the rows, but for the first column, it'll just give me the first column, but all the rows, right? Okay. For the Pandas data frame, we can also use the ilock method, okay, to extract the most common or the different types of segments that you want. So earlier, I did df ilock for all the rows, but the first column. Now, I can extract just the first row, but all the columns. So that just requires me to do df.ilock, right, into 0, which is the first row, and all the columns, right? So this is just for John, but this is very similar to just if I don't even do this, right? The same output, right? So yep. I think even without the comma, yeah, same. So if you want an exact specific value in your data frame, you have to pass in two specific values, right? So df dot ilock, and then I pass in 0, which is row 0, but this is the second column, which is 4.2. Let's see. Yeah, 4.2, right? That's what it gets. Okay, using lock. Okay, besides ilock, you can also use the LOC function. Okay, the LOC function works differently. So let's try to pass in the year, the column name. Okay, the LOC function takes in the column name. Unlike ilock takes in indexes, the LOC function takes in the column name. So let's try this. df lock, yeah, 2005, and that should work, right? No, it throws an error. So what's the error? The error here is, let's see, the key error. There's a key error. So in order to use your ilock, you need to use, as I said, dual indexing, not single indexing. So you just can't pass in the year 2005 in string. You need to pass in df.loc with all the rows for this column, right? And it works perfectly, right? You can also get the exact name. You pass in the exact index name plus 2005. You also can get the exact value, 4.2. Okay, quick practice. You're supposed to define an array variable, weight array, assign a pandas data frame variable from it, and you're supposed to display the last row and last column using ilog and negative index approach using print function, and also display the last row and last column using ilog. Actually, exclude the print function. Do it without the print function. The print function, actually you can do it with the print function, but yeah, I mean up to you lah when you use the print function. Okay. So how that works basically is, let me go and copy. I don't want to go and, actually it's okay lah. Let me just type it out. Yep, sorry, let me just type it out. Weight array 2D equals to, let me just paste this. Yep. And then let me create a pandas data frame called df is equals to pd dot data frame, and pass in weight array 2D. And after that, let me, I want to display the last, yep, wait, before that, I need to create my columns. My bad. Columns equals to this, right? If not, my columns are zeros and ones, and my indexes equals to John and Wilma. Also passed in as a list value. Do remember that your list, number of lists and your columns must match properly to your data set. So I'm going to print basically df.ilog -1, comma -1, and that gives me 0.8. So that's the last column, last value. Now I'm going to get Wilma's value using print df.loc. I want to get Wilma, indexed by Wilma, and the year 2010, which is the last value as well. Right? Oops, what did I do wrong? Sorry. The bracket here. My bad. Yep, 0.8. Cool. Yep, that's all for Pandas. Quick review. Right? Let's move on to matplotlib. Okay. Similarly, for matplotlib, you need to import the packages. So in this case, I'm going to import matplotlib. Do install the matplotlib library using pip install if you do not have Anaconda. Right, so matplotlib dot pyplot splt, right? And also import numpy as np, right? Just basic practices. Let's create a x array, a numpy array equals to np.arrange 10, 100. I want 10. I want 10 to 100, and I want 10 them separated by 10 numbers each, right? I can print it out to show you how it looks like. Print x array, right? And I also want to have a y array, almost said y variable, right? Using np arrange from 1 to 10 with 1 space steps, and I print y array. So just see how they look like. So you can see the data points are quite simple: 10, 20, 30, 40, 50, 60, 70, 80, 90, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Simple. So you're going to use a PLT graph. So it's just a linear graph. So you're going to do a PLT dot title. So this is to set the title. We call this line graph, right? And you're going to label the axis. So whenever you plot something, you need to label the axis. So PLT X label, right? I'm going to call it the X axis for the lack of a proper name. PLT.Y label, I'm going to call it Y axis. Right? And then I'm going to PLT.plot. So this is the plotting part. This is the most important part. So I pass in my X. Usually you pass in your X first, and then your Y, and then your color. So you can choose what color you want. Usually the safest is to go for red, blue, green. And we do the most important step called plt.show to show your plot. So you can see that you have a linear line. So this y-axis is 1, 2, 3, 4, 5, 6, 7, 8, 9. And x-axis is just 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. With that, let me change the color. So if you want to change the color and the style, let me just copy all the way till here and just paste it here so that I don't have to re-copy it, right? And you can plot the X array and set color to blue and do some fancy stuff, right? plt plot X array, Y array, and then I can do something like color equals to blue, as I said, the safer colors, right? There are definitely online, you can definitely find ways to customize them, right? This is not the course for you to customize them. This is basic at best. Okay, there's definitely a lot more customization that you can do. As you can see, it's a line graph, very nicely built. Okay, you can also plot a histogram, right? A histogram usually just gives you the distribution of a variable. So in this case, I'm just going to show you a simple way. There is no real reason behind plotting this histogram. Okay, I'm going to use an np.random approach ran int integer between I want to get 1000 values between 10 and 100, right? And I'm going to plot the values for it. So plt.title histogram, not histogram, histogram, right? And you can just type to plot it. You just plt dot, you call out the histogram function, pass in the ran integer array, comma, how many bins, 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 I'm just going to pass in 50. That's it. That's as simple as it is. Very, very simple, right? Then you just do a plt.show to show it out. So you see this is what you get. Histogram, right? Not a very nice one, right? I mean, there's no real reason for drawing this. Okay. Similarly, to do your task, you have to define an array variable ran int array with the ran int method, with the random method with 10 as the first parameter and 100 as the second parameter and 200 as the third parameter. Using the histogram.plot, use the plt function with the hist method on ran end array as the first parameter and bin set to 20. So it's quite simple. You can quickly do it here, right? If you want to try it out, you can definitely try it out, right? So let's do this. Yep. Sorry, there's a typo here. This is supposed to be int. Just realized. Yep, the ran int array, not with the ran end array. Ran int array. Okay, so ran. Let me just copy it from the top. I'm really lazy to type it again. So it's basically from here, I can just copy this and change the values accordingly, right? That's oops. Okay. Okay, so when I paste it here, first 10, second 100, here is 200. And then here is histogram, title, ran in array, bins is equals to 20 and plt.show. Yep, that's all, right? And it works. Yep, that's it. That's the end of the lecture, the end of this course actually, right? So until the next course, thank you so much. Do subscribe, share, and I will see you soon. Bye.